Hi everyone and welcome to another Stemiverse episode. Today I have the pleasure of talking to Dan Mantz. Dan is the Chief Executive Officer and Chairman of the Board for the Robotics Education and Competition Foundation, REC, and has more than 25 years of experience in the fields of software, electrical and mechanical engineering. As the CEO of REC, Dan has a unique perspective of STEM education, robotics, and how competition can propel learning and inspire the world's next generation of engineers. Given that we are now more than a year into the COVID-19 pandemic, I'm keen to learn how REC's competitions have evolved to deal with the difficulties and risks of holding live events that involve domestic and international travel and a lot of people and their robots. Dan, thank you for joining me. How are you today?
I'm doing really well, Peter. Thanks for having me. And we're really excited to share our message with your audience, especially all the Australians out there, which we're really excited about because we have a great program in Australia also.
Yeah. After you contacted me, I was aware of the REC Foundation and its work, but I took another look in the last few days. I was preparing for this interview, and I've got to say that I'm impressed, especially because of the growth that you have achieved during the COVID-19 pandemic, and we'll get into that as well. It was something that is very interesting to me, how an organization like yours that is based on like a face-to-face events evolved to take, maybe not advantage is the right word, but to evolve along with what is happening around us in the world and grow instead of losing time and I guess losing steam during this time. So just in case one of our listeners is not familiar with the REC Foundation and its mission and its work, could you take a few minutes to tell us what is the REC Foundation as an institution and describe what its mission is?
Absolutely. So the Robotics Education and Competition Foundation, so REC Foundation, as you said, we've been around for about 15 years. 13 years as a not-for-profit. And basically, we're trying to increase student interest in STEM, which is science, technology, engineering, and math, by using hands-on, affordable, and sustainable robotics engineering programs. So that was the basis of what we started 15 years ago. Over the past few years, we've actually expanded quite a bit. So while our mission hasn't changed, the activities that we do to accomplishment have grown. So we're probably best known for our VEX Robotics competition, which is close to 30,000 teams globally, impacting almost 350,000 students participated in the pre-COVID year. We're in over 70 countries, and that's, like I said, probably our most well-known program. But over the past couple years, we've also added multiple drones programs, and we've added a factory automation competition that really focuses on workforce development. And all those activities are supplemented by our online educational resources, which include STEM labs, a knowledge base, and online challenges. So again, VEX Robotics is mostly what we're known for, but we're so much more now because one of the things that we realized, and my background is industrial robotics, I spent 20 years at FANUC, but one of the things we realized is not all students want to do mobile robotics, but we think all students need an opportunity to at least try a STEM activity. So we think that drones and online challenges and some of these other activities really gives more students an opportunity.
So robotics is, I guess, the flag post, like a flagship, actually, objective of the REC Foundation. But over the years, you've expanded into other areas. Still, though, automation is a strong component of what you do, whether it's industrial, robotics, obviously, and you introduced drones as well. Could you tell us why the focus in automation? Do you see perhaps as this being a very useful skill for people to have in the future, the way that, the economy and technology is heading, something else perhaps?
Yeah, yes, absolutely. I mean, it's really important that our programs provide students a fun activity, but also addresses the global workforce shortage. I mean, not just in the United States and Australia, but globally, STEM jobs are growing at a much faster rate than non-STEM jobs. I mean, artificial intelligence, Industry 4.0, robotics are becoming more and more common. And we feel that our programs help bridge that gap. So we'll always need engineers and mathematicians, and that's a lot of students in our program, they go into the traditional STEM fields. But even in our day-to-day operations, students in our programs will now go into the manufacturing jobs, or they'll go into the robotics jobs, or they'll do a technical job that's not even in a traditional field, such as home robotics. We actually have a few alumni that are working for some of the home robotics companies. And more importantly than even just the robotic skills they're learning the soft skills, which is communications and troubleshooting and problem solving and collaboration. All the students in our program learn those skills. So whether they choose a STEM career or a technical career, or they go into banking or legal or something like that, those problem solving and communication skills serve them well too. But again, we want more students to be engaged in technology. That's our primary mission. And we think that our robotics platform and our drones platform is a way to accomplish that.
Yeah. In my experience, I find that, you're working with robotics is multidisciplinary, not just in terms of the kind of technical skills that you need. So you need software development capabilities, mechanical development capabilities. There's the user interface aspects. There's the cloud now. There's so many things that can come in. But because of the complication there, you also need a lot of people. And that's where the soft skills come in as well, especially in a team environment like what happens in a real REC Foundation event. So I can see why you can even become a lawyer by learning.
Absolutely. I mean, absolutely. And I think at the end of the year, and I tell this story a lot, at the end of the year when parents come up to me or coaches come up to me, rarely do they talk about the technical skills they learned. I mean, it happens once in a while. Someone will say their student is a much better programmer, or they really love mechanical engineering because of their experience. But overwhelmingly, 95, 97% of the time, parents and coaches come up to and thank us because they really improved again, what we call the soft skills, but the communication skills, the problem solving, the working under pressure, all that set of skills. That's what they've really, really learned from our program. And those skills transcend any industry. I mean, creative thinking, collaboration, communication, those are what every employer is looking for. And, interestingly enough, we just had a keynote speaker at our most recent event, and she was a lawyer. And I thought her message about how robotics helped her was fantastic. My daughter, one of my daughters, all three of my daughters have been involved in robotics. And one of them is a marketing major right now. So you wouldn't say it's a traditional STEM skill, but she's done a fantastic job of leading teams and problem solving skills that I think she learned in robotics. Wow. So again, we are happy with the technical skills that we teach, but it's really about providing students a well-rounded opportunity.
I think you've already answered my next question, which was just to talk about a few of the tangible benefits that the foundation has achieved over the years. I think you just mentioned a few people that went through the program, didn't go into a, engineering style career. They did other things, but they took a lot of benefits from their experience with the REC Foundation events and going through the program. Is there anything else that you could add into the success stories that came out of the foundation's work?
Yeah, so absolutely. So if we look back at our core mission about getting students involved in STEM, there's some data out there from universities studies that we've actually funded, like with Georgia Tech and Utah State. But what some of the most interesting data is that, 89% of the students in our program are more likely to study STEM courses in college. And 97% of our students now understand engineering, and 83% plan to take technical courses and future ones. And 87% want a job in a STEM or computer field. So those are some of the tangible. We're at a point where over half the students in our programs go and pursue a 4-year degree. But I'm just as excited about the students that don't, because one of my favorite statistics that I like to quote is 50 students that compete in our programs participate their industry certifications in 50% of the time. So basically, if you've been on a VEX robotics team or on a drones team, and now you go into the workforce and you need to learn your industry skills the students in our program completed in half the time.
Wow.
So we have doctors, we have lawyers, we have NASA astronauts. We have a lot of those high profile positions, but we also have people working in factories that are maintaining the robots or teaching the robots, or they're working on guided vehicles, and they may not have their 4-year degree, but they're valuable contributors and they're earning a good salary. They have job security, and they're keeping manufacturing jobs in Australia or in the United States or Canada or anywhere where our programs are.
Yeah, perfect. And is it true that you are, like the way that the program is structured, you are, I guess, bringing in students from diverse backgrounds, boy, girls type of balance in the teams? And is it something you can say about this?
Yeah, absolutely. So, in 2016, it became quite the crisis in the United States, but globally, that people with diverse backgrounds, people underprivileged is what we call it in the US, and women in STEM were very underrepresented in STEM jobs in the workforce, less than 20%. So we took a hard look at our own program, and we realized that only 23% of the students in our programs were women, for example. So we started our Girl Power initiative. And every year through seminars, through lots and lots of grants, we give out hundreds and hundreds of grants a year to start teams with girls, young women, through our online challenges, through great sponsorships like with Google and Texas Instruments. We've been successful. The past year, 43% of the students in our programs were women. And in our elementary and middle school programs, it's actually over 50%. So we're hitting that goal. But we also have other initiatives. One of our most passionate initiatives recently is our Native American initiative, right? So in the United States, Native Americans are even more significantly underserved in STEM jobs. It's under 3%. Wow. So we've partnered with Native American tribes, and we've started programs throughout the US. And we literally have success stories where students didn't enjoy going to school, and now they stay every single day to be on the robotics team. Their grades have improved. They're graduating at a much higher rate from secondary school. And then, of course, we also have initiatives for Hispanic students, for African-American students. We have all those initiatives, but as an ecosystem, it's one of the pillars of what we do at the REC Foundation. We don't want to just reach the students that already have those advantages. We want to make sure that everybody has the opportunity, because frankly, when students get the skills in our program, and other programs too, not just ours, they go into their workforce or they go into college with much more confidence, and they're more likely to stay involved. And then that's what's really, really important.
Wow, that's impressive. And it could be a topic on its own to discuss how you do it. How do you approach underprivileged young people, underrepresented? Maybe in a nutshell, you could give us some hints. For example, do you modify programs to make them more appropriate for women, for example, or Native Indians, or Hispanics? Or is it in the messaging, perhaps, on how you invite them to become part of the foundation's work, or perhaps both, or something else? In a nutshell, could you tell us what it is?
I think it's a multiple approach. So, for example, like we have a program for students with disability, so cognitive learning lessons. But even then, we don't radically change our program. So in our elementary program, it's 1 minute for a match, and we increase it to 2 minutes. We partner with leading organizations in the U.S., so the National Society of Black Engineers. Together, we recruit underrepresented groups to give scholarships and grants to. But I think what we really do that's probably, I think, the best impact long-term is for our Girl Powered and some of our other grants. We don't give it to just start girl teams. So we have these, we give it to make the teams inclusive and represent what society is. So we have some great workshops, and the Googles and the TIs and the Northrop Grumman send speakers, and we make it fun. We do fun activities. We have cookies, give out shirts. But what we really do is we give a lot of grants out. I'm talking hundreds and hundreds of grants a year. Probably for our Girl Powered, it's about 600 grants a year for the young women to actually join a team. And sometimes they join an all girls team, but probably 70% of the time the team is at least has one young man, one boy. And average it's 50-50, right? So what we're doing is we're giving the girls the opportunity And then we have a lot of instruction on making sure that girls have a chance to drive the robot, make sure they have a chance to build, because our data shows that boys grow up playing with Legos and cars and stuff like that, and sometimes the girls don't. But the girls are often a lot more confident in journal writing, the engineering design process. So what we really try to do is, hey, the boys should take part in the engineering design process, and the girls should get a chance to drive and maybe wreck the robot, to build the robot, to definitely program the robot. And I think when we get students at a young age before stereotypes are formed, it takes care of itself. So that's, at the beginning, we focused a lot of our diversity initiatives on high school, but right now my focus has been on elementary and middle schools because we want to get them before those stereotypes take place.
Yeah, very true. Great. It's clearly working. So yeah, this is something for everyone to look at as an example of what is possible to do. I'd like to switch to another topic now that is, again, is in the core of what the foundation does, and that is competition.
Yes.
So, in traditional education, things, I guess, they're competitive in a way where you do some work, you get a mark from your teacher, but that mark is not really for you comparable to others. The teacher knows how I compare against others in the same class because of the mark that I received, but that doesn't come to me, so I have no way of knowing. But in the work that the RSC Foundation is doing, this is core. You've got competitions. The events are competitive. You've got winners. You've got losers. Mm-hmm. But somehow education does happen, and it seems like the participants, whether win or lose, are extremely happy to come back and to try again. So can you tell us how you got this to work, and what does it mean what does competitive education really means for you?
Sure. I mean, so in many schools in the US, Australia in particular, there are technical classes, engineering classes, and these schools use the VEX Robotics curriculum, right? So VEX Robotics is one of the leading STEM education companies in the world. And so we'll get teams started because they're doing VEX in the classroom. But over half of our teams are doing it as what we would call an after-school activity. But it's complements is the word I would use. It complements traditional education. So the first area that I think it really does well is it teaches the soft skills that we already talked about. I won't rehash it, but when you're on a robotics team and you're competing, your communication skills, your troubleshooting skills, and your teamwork collaboration skills really, really develop. So that's something that probably develops better in an extracurricular activity than maybe in some classroom activities. The other things it does is it really reinforces what you're already learning. So my best example that I like to say is gear ratios. So there's always a trade-off between power and speed. And you may learn that in your math class or more likely your physics or science class, but you see it for real in competition robotics, and that reinforces it. And we do complement education by providing STEM labs and knowledge-based articles for free. So all the educators in our programs get all these resources, and we literally use examples of changing a drivetrain on a robot for torque versus speed, or looking at different mechanisms. So defining what a 4-bar link system is, dividing what a gripper system is. And these are all hands-on activities that make it fun, but also reinforce what you're learning in the classroom. So I think it's twofold of A, reinforcing the technical knowledge, but B, increasing the soft skills, the troubleshooting, and the what I would also say creative thinking, and together the data shows. I mean, the data is very verifiable from multiple organizations, not just the REC Foundation, that it has a very proven positive impact on participants. There's many, many studies out there that show that students increase their interest by 3-fold in STEM, or they will pursue a STEM career 4 times, or they improve their problem-solving skills by 98%. I mean, there's much data that shows that competitions work. It should never replace traditional education, but it should definitely complement it.
Yeah, I think also a big aspect of the reason why such type of competition, educational competition, is beneficial is also because of the team element. So these are not solo competitions. You've got teams against teams. And as you were talking about gears and gear ratios, I was actually thinking of people, like people as gears in the team. And then they've got to match each other. I guess the chemistry has to be good. The cooperation has to be good in order for the for the team to achieve maximum torque. So, and also just to conclude my thinking process here, the people in the teams tend to be young people, I guess, in elementary or maybe high school. At least in my time when I was in high school and elementary school, there were no team educational activities. You just had sports. Maybe you were in a team in a sport, but not, learning geography or mathematics. There was no engineering back then in school. In your case, you put kids in teams to go into a competition. So that, I guess, that is in a way unseen in other educational contexts. Can you tell us about how kids in your competitions tend to mature when you compare the same child in the beginning prior to joining a team, and as they go through the tribulations of being in a team, getting ready for a competition, and then after the end of the competition? How has a child evolved or matured?
That's a fantastic question. I don't think I've ever been asked that question before. But so I think we always talk about the teamwork and collaboration, right? We've already said it multiple times today. So when you join a robotics team, you are going to have a role. It is not an activity, and we like to even say it's a sport. It's not a sport or activity that you'll excel by yourself. So teamwork is the key. And that's, again, what the parents and the coaches always come up and thank me for, is the teamwork, problem solving, and communication skills. So a good example is on a Vex Robotics team, you're going to have someone who's primarily the driver, or maybe two drivers. You're going to have the programming lead, or maybe two programming leads. You're going to have the person that does the building, someone who does the CAD, and you're going to have someone that does the design process and documents that, and someone who's strong. But what's amazing is when these teams come together, the roles will often change. So you may come in thinking, I'm going to be the biggest builder, and it turns out you have a really good aptitude of understanding the design process. Or the really quiet person has never said anything but joins a robotics team, now all of a sudden is the best person on strategy, or maybe they're the best at programming. I mean, I can't believe how many students in our program have actually never programmed or coded before, and then they join the team, and all of a sudden that's what they want to do, is major in computer science. So you join it in order to be a successful team. All the parts have to work together. Teamwork is absolutely essential. And I think there's so many different opportunities that everybody finds their niche, and that's where they really gel.
Wow. So there's also an element of self-discovery there.
I think so. I think maturity, I think that's one thing we see in our program. I've seen it with even a couple of my own kids, right, that join robotics. And you can't be that, but that obnoxious, loud kid and thrive on a robotics team. You're going to get called out. And if you want to belong, you're going to learn to be respectful. You're going to learn to be polite. Matter of fact, at the REC Foundation, one of the first things we implemented after I joined was a code of conduct. So we clearly lay out the expected behaviors of the students and the coaches and the parents too. So sometimes parents can be a little bit passionate. So that code of conduct, if you want to participate, you agree to the code of conduct, and we do enforce it. And the other thing we do at the REC Foundation is we're very student-centered. There's other organizations that are about different skills, but we believe that the students thrive if they're hands-on. So we literally have guides for coaches and parents on how much is too much and how much is appropriate. So you've got, yellow, red, and green. Red, you're doing too much for the students. Yellow, if they're learning, if they're emerging, that's the appropriate input. And then green is students are doing it all. So we think that those combinations of the code of conduct and the student-centered really help the students mature, to have a great experience and honestly be better adults.
Perfect. I've got another relevant question, then we're going to move into something else, like more organizational aspects of the foundation's work. So I can imagine a young student hearing about the REC Foundation work and maybe its events, maybe a friend told them about it, and they're thinking of joining. They go to the parents and say, I want to join. And they eventually do. I wanted to hear about your experiences in relation to the kind of motivations that parents and the kids that are joining have when they're at the beginning of the journey. And then whether you think that they have achieved those objectives and motivations that they had coming into the REC Foundation and its events, and whether those have actually been superseded by some more important things that you just mentioned a few minutes earlier. So I want to, basically, whether the hook in joining the REC Foundation's work is something else, let's call it A, but then the real joy, the real achievement is something else, which is B, which they don't know coming in until they come out of it. I hope my question makes sense.
Yeah, it does. And I think a lot of people join robotics. The parents will push students into robotics because they're worried about their students having employable skills, right? So everybody has now heard the word robotics, and robotics are such an important part of our future. So join a robotics team, they'll learn the skills. I think that's one of the expected outcomes when parents or teachers start a robotics team. Again, I think the surprise to them is how they've evolved as a person, that they're much more confident, they communicate better, and then there's a joy too. I mean, students really love being on a robotics team. They really, really love competing. It's one of the reasons the REC Foundation chose to have a season with the global pandemic when most organizations didn't, because we realized that you can do so much what I would call virtually, right? Because in the REC Foundation, virtual and remote are different, right? So a lot of students were doing virtual, but we thought hands-on was still key because of those outcomes of working with other students and competing against other students. That's such an important part. And I think that's probably where the parents are most surprised, or the coaches, is how much the students really love the community. I mean, Discord and all those chat rooms are just full of thousands and thousands, I shouldn't say thousands, hundreds of thousands of students that communicate across the globe because robotics is now their passion. It's like, it's like rugby in Australia or soccer, those have those passions, and students in our program are just as passionate. We have a life-changing, I don't want to overstate it, but our programs are life-changing to some students because they didn't have their place and they join a robotics team, and that becomes their social circle, their friends, their reason for going to school. And I think that's what surprises the parents, is they get the technology skills, but they really learn to be part of a community.
Yeah, and a new way of thinking, which doesn't come often with, those types of activities.
Yeah, and Peter, I can't wait to talk about how we did COVID, but the one thing is that I've been messaging a lot is that robots is a universal language. So with over 70 countries in our programs, and I think we'll be 80 very soon, and my goal is to be 100 by the end of the next year. But the one thing that students speak is the robot language. So when you come to a VEX Robotics World Championship and you have China competing against Australia, against New Zealand, against Canada, and of course, within the United States, the culture in the Northeast is much different than the South, and there's accents and stuff. Everybody can communicate. It's a universal language. And what I love about the program, and I've said this in one other interview, so this is the second time, is I think it brings down cultural barriers too. And it's an unintended benefit of our program that I learned. I think people are more tolerant because now that student in Louisiana or Texas is mingling with the student in Washington and Oregon, or the student from Spain or the UK is competing with New Zealand or China. And I think there's an awareness that at the end of the day, we're all students. We're all stressed about grades. We're stressed about dating. So I think robotics, an unintended consequence of this, is it brings cultural awareness and I think tolerance too. And that's kind of a deep thought, but I truly believe that. And if you come to any international VEX Robotics competition, you will see that firsthand.
Yeah. Competition in my mind brings up sports, and the word I think fits very well with what you're talking about is sportsmanship. So you've got really true sportsmanship in a robotics competition where competitors actually help each other to do better.
That's for sure. I mean, again, we actually say sportsmanship in the REC Foundation Code of Conduct, right? It's a key word.
Wow. All right, let's get into the how now. How an event works. And of course, now we talk about how pre-COVID and then how during and after COVID. So maybe give us in a nutshell how an robotics event took place pre-COVID, and then some of the biggest changes that you had to undertake in order to make this possible to continue during and post-COVID.
Sure. So the REC Foundation, when we run our VEX Robotics competitions, pre-COVID, we were up to almost 3,000 competitions globally a year. That's 3,000 competitions. But what's interesting is the REC Foundation doesn't run them directly. We rely on a network of volunteers called event partners that host the competitions on our behalf. So in Australia, for example, we have a couple dozen event partners that will actually host the competition. And what they do is they work with the facility, which is often a school. Our program doesn't believe in, very expensive venues, except for our national and world championships. Then we tend to go big for those, but they're often in a school. So the event partner recruits the volunteers, they recruit the referees, they recruit the judges. And of course, we have very strong guidelines on how they have to be trained and acted, but they also keep the registration fee. So most events have a token registration fee. In the US, it averages about $55 per team, so not super expensive, but the REC Foundation doesn't keep the revenue. We rely on our event partners. So we have this massive network of 3,000 events that are run by volunteers, for a better word. And our events tend to be 30 to 40 teams because of the price cost being so low. Teams compete an average of 5 or 6 times. And the REC Foundation oversees it all, and then we have our national championships. The national championship in Australia is absolutely a spectacle. It's a fantastic event, but that's where we start bringing in corporate sponsors. SMC, for example, I know is a sponsor in Australia. And I know our Australia team would be very mad at me right now because I don't know all the Australian sponsors, but globally, Northrop Grumman Foundation, Google, Dell, Tesla, and Texas Instruments and NASA are our biggest sponsors. But anyway, so we culminate in these, and they're in person. So at VEX Worlds, we have teams from 50 countries competing. We have over 30,000 competitors. They're from all over, but you're bringing in your robot, you're physically competing on the field. And that's how we ran our organization. And then all of a sudden the pandemic hit and
Yes.
Everything had to change, right?
So what happened during the pandemic? I guess in the beginning, where things were a bit uncertain about how long this is going to last and what does it mean? Should we cancel, postpone, change? What was it like for the REC Foundation at that point?
Well, it was very stressful. We'll start by saying it was very stressful. So we were monitoring it in January of 2020, but we were with the REC Foundation. As CEO, one of the things I decided to do is always defer to the guidelines of the country, of the state, or even at the local level. So we were still having in-person events, but by the end of February, there was travel restrictions everywhere. But by then we had been able to finish about 95% of our season, but we did have to cancel our VEX Robotics championship that was scheduled for Louisville, Kentucky in April of 2020. So we had a celebration. We did a lot of virtual events. We gave out awards. But even though things looked like they were getting a bit better, we realized by midsummer, we were realistic. We realized that we were still not going to have a lot of in-person competitions for that calendar year. Now, we were hopeful that things might change for 2021, but we knew in 2020 it was unlikely that there would be a lot of travel. Some countries were better than others. New Zealand, for example, had a lot of in-person competitions, but it depended. But again, what I was saying earlier is we know how important it is for the students to play with their robots and to compete with other students and against other students. So we made a very strong decision to develop an infrastructure, a peer-to-peer infrastructure, and to modify our game so that we could connect teams from across the globe. And we had the brainstorm concept in late July. And then by October, we had practice matches. So that first practice match in early October was run out of the REC Foundation here in the Dallas, Texas area. And we connected 3 local schools in the REC Foundation, so 4 fields, and we connected it and we actually ran some matches. By November, we were actually running real competitions. Our first competition had United Arab Emirates, Turkey, California, Kansas, Canada, and we still had some bugs, right? So one of the things we originally did was a huge peer-to-peer network, but that's a lot of connections with a lot of computers. So we streamlined the video feed, and then by early January, we had a pretty robust system. So in January, even though within the United States, we had pockets of places opening up, we knew that it wasn't likely that international teams were going to be able to travel to the United States for our World Championship in April. And even within the US, we knew that places like the Pacific Northwest, so Washington, Oregon, California, and the Northeast, like Massachusetts, the New England area, we knew they weren't going to come. So we made the very, very difficult decision of canceling our in-person Worlds, but we didn't cancel Vex Worlds. We decided to double down on this live remote technology platform. And we said, we're going to pivot. We're going to have a live remote tournament, Vex Robotics World Championship. So we sent a requirement to, so this past year, our registration was down, but we were still over 12,000 teams. And we said, if you want the chance to compete at Vex Worlds, you need to sign up for 1 or 2 live remote tournaments. And literally, it was fantastic. So we had Australia competing against California. We had New Zealand competing against Texas. In any given event, and we hosted 20, 30 events a week, we had teams from all over the world competing. And so by the time we got to our World Championship, which we delayed a month, we had it in May instead of April to give teams more time to get experience. We culminated last week with the world's largest remote robotics tournament. So we had almost 1,700 teams. I think we ended up at 1,690 teams competed from 35 countries, and they competed doing real robotics. So how it works is each team has a field. That was one thing that changed a little bit, is every team had to have their own field, and they were connected with a laptop and a camera, and we connected the robots. So we still started and stopped the robots remotely. And we had control centers all throughout our offices here in Greenville, Texas. And we started and stopped, and we had judging. I mean, one of the things we had to change is how we do judging. So we went from in-person judging to remote judging. Our engineering design notebooks, which were physical notebooks, we allowed electronic notebooks. The game, which was a kind of a back and forth game, we changed it to a scoring game. And at the end of the 2 weeks, we crowned multiple world champions. And I'll tell you what, the level of the competition was exciting. It was as good as an in-person event. It wasn't the same experience, but because of the chats that we developed and all that other stuff, students still talked to other students. They had to collaborate. Our world champions have all won world championships by collaborating with their partners. And so we really were able to replicate an in-person event and have it remotely. And it wasn't virtual, it was remote, because it was real robots on real fields using real game elements. There was nothing virtual about it. It was a real robotics event. And we were recognized by the Guinness Book of World Records as having the largest remote robotics tournament of all time. So we ended up having about 13,000 participants. And again, about 1,690 teams, I think, was our final team count.
It's amazing, and especially how quickly you were able to implement that. I'm just looking at the website, roboticseducation.org. There's information about the various types of competition, and the one that you've been talking about, I believe, is the live remote World Championship, and that's at 2021, which is coming up. And there's videos there for anyone curious about how it actually looks like. You can go to that page, just go to roboticseducation.org, then look for live remote, and you get a lot of information about it there.
Yeah. One of the things we wanted to do is make sure the students had a great experience. So we still brought in a high-tech audiovisual company. We created a studio with all the lights and bells and whistles. And, we had recaps every morning and afternoon where we highlighted teams. We had opening ceremonies where we recognized, it's called our Flag of Nations, where every team that's participating from every country is recognized. We had a awards ceremony. We announced next year's game. We even had a fun meme contest. Every students were able to submit memes. So we added a lot of the pizzazz that you have in an in-person event. And most importantly is we encourage the students to interact with each other. And honestly, right before we got on this call, I was meeting with our student advisory board. So I have 12 students selected from across the globe. Matter of fact, one of our students is from Australia, and he was on the call. And we asked them what their experience was. And they said a lot of people were skeptical going in. We're talking teenagers, right? So they're always skeptical, but it was universally well praised because it did what we needed. It gave students some excitement. It gave them an opportunity to interact. And it's never going to replace an in-person tournament, but it is going to complement it. We think our live remote technology is here to stay. It allows us to reach places that can't travel, and they can still now participate in robotics. So it was a lot of work. We did it in 9 months. and we did it with 2 developers. So one of the things the REC Foundation did is we took a lot of our staff that, their skill sets weren't being utilized. People, for example, in the operations team, the warehouse, the shipping. We took people that did documents, and we taught them the new skills to run all these events too. So the REC Foundation really pivoted to use our staff so that we only needed 2 professional developers, and we ran most of the events ourselves. Again, we transformed how we do judging. We also offered online challenges for those students that were just not going to be able to compete in robotics at all. We provided online challenges so students could still do STEM activities and compete in activities. And then even our drones program, we pivoted our drones program to add a virtual. So this one was virtual. It was basically enhancing your programming skills. And then our partner, Vex Robotics, they released for free Vex Code VR. And it was for students to learn coding. And at last check, over 1.6 million students across the globe, 1.6 million students, unique students, have used Vex Code VR to improve their coding skills. And they've written 95,000 or 995 million, not thousand, 95 million programs have been written through Vex Code VR. So we did something unique that was unprecedented, and honestly, that was the right word with the competition. But we also provided online resources such as coding and STEM activities for those students too.
It's amazing. So if I understand right, the drone VR program from Vex Robotics, if I understand right, you fly your drone in a virtual simulated environment, right? It's not a real drone that flies in like in the oval here nearby. It flies in virtual world, but the programming is the same. You could take the same program and upload it onto a quadcopter, and the effect would be the same. Am I understanding correctly?
Yes. So actually, we have 3 drones programs, to be honest with you. And the first one is our RAD-C. So that's our drones competition. That's a physical drone. And it's actually, we partner with For the Win on that one. It's not a Vex product. Yeah. Then we have our Bell Vertical Robotics Challenge, which is a helicopter drone project. And that's where it's very large drones and they do multiple missions. But the one that we're specifically talking about is VRAD, which is our virtual drones, and that's exactly what they do. It's a 3D environment. They're giving a basic drone, and they have to program it. And so, if they program it to go faster, then it's a little bit harder to control, right? So, the better you programming it, the more skills that you can do. And that was something we quickly developed. Our partner for that one was Robotify out of Ireland. So we didn't develop that ourselves. We partnered with Robotify. And again, it was a way for students to actually improve their programming coding skills and still have a lot of fun. And we had a world championship for VRAD too. We actually, the top teams from around the world competed, and they had coding challenges and had to fly their drones for missions, and it was super successful. And just like in-person robotics, the attendance was down this year, but our in-person drones programs are still thriving, and so I think everybody knows what a drone is, but our in-person drones is like doing rescue missions and flying through hoops and speed and maneuverability. So all those programs existed, but the live remote for our Vex Robotics program and then our virtual drones program were probably the 2 that we adapted most for COVID.
Yeah, it looks amazing. I'm looking at the VRAD Martian Survival Challenge.
Yes, that was it. Yeah. Yeah, so NASA, we found Robotify and that was good. But then we wanted to be able to develop a nice challenge, and of course, all that stuff costs money. And it was great because NASA actually came through and gave us some funding to help develop that program. And again, that's going to come back. We think one of the things we learned is all the programming was in Python, and that was a little bit advanced because on our Vex Robotics competitions, we can start with block programming before you go to Python or C++ or some of the more advanced languages, but every student has the opportunity to start with block programming. So for year 2 for VRAD, we're going to have the same option where you can start with block coding, and then as you get more comfortable, then you can switch over to Python. So year 2 will even be more fun than it was in year 1, because all the things we learned from COVID, from the global pandemic, there's a lot of things we learned that will transform the REC Foundation. I think the example I like to give the most is the engineering notebook. I'm a big believer in the engineering design process. It's a core part of our program. You can't win any awards without doing a design notebook. And I'll be honest with you, I was stubborn. I was saying that we needed the physical notebooks because I personally believe writing things down is important. But we couldn't do that. Exactly. You have one here and mine's right here. Exactly. I keep
always paper.
Yeah. And so maybe we're showing our age, but I think that design notebooks are really important. But we couldn't collect notebooks. We couldn't do judging with physical notebooks. So we did do online notebooks, digital notebooks, and we added time stamping because the one thing we don't want is students to write their notebooks in the last 48 hours, right? It needs to be every meeting you do it. So we time stamped them. But then the judges got to, because it was all digital, so instead of the judges doing all the judging of the notebooks and interviews the day of the competition, they're like, well, they're digital. So now they're judging on Tuesday and Wednesday. So when the event happened, that part was out of the way. So I don't think we'll go back from that. I think we'll always now allow the option of remote judging and remote notebooks. And again, I don't think our virtual RAD will go away. I know the VEX Code VR program, VEX, when they launched that, it was some basic coding, and then they created all these really cool activities like an underwater activity. So I do think that fundamentally, the pandemic, while none of us wish it would have happened, made us reflect on what we did and make some changes that honestly will allow us to reach more students. I mean, LRT will allow us to reach areas where students can't travel. I think it'll allow us to give. We've probably started VEX teams in 20 countries in Africa, but maybe only 3 or 4 have ever traveled to a competition. So now all those countries will be able to compete, right? Yeah. And more students will be able to do drones because of this. So we fundamentally had to pivot and adapt because of the pandemic, but that's what we ask of our students too, right? We ask them to pivot and look at the design process and make improvements, and it forced the REC Foundation to do the same thing.
Lead by example. Okay, I've got 2 questions left.
Okay.
The first one is that a popcorn machine in the corner behind you?
Peter, it is. And the funny thing is I normally have a jukebox there. So I joined the REC Foundation 4 years ago. Prior to that, I was president of a company called Rack Solutions. We made data center products. So we did engineering, design, and manufacturing right here in the US. We were a leading supplier of data center racks. And when I took the job with the REC Foundation as a thank you gift, they bought me a jukebox. And that's normally what sits in the corner. But for VEX Worlds, I actually took it out of the office and we put it in like our lounge area so that everybody can enjoy it. But for the call today, I didn't want that empty space there. So I have a popcorn machine. I also have gumball machines in my office too. I try to make it a little fun. So
it's very interesting. Normally people have books and things like that, degrees, but I like what you've got there. Take your example and do something interesting with my background. All right. The second question is, and you really have covered a lot of it, is I want to look into the future of the REC Foundation. I will say that I do expect a drone, a student-designed drone on Mars sometime in the future. Okay, NASA has done it, but I think you guys can do it one day. So what is the future like, say, in 2021, so the near future, maybe looking a couple of years, because you've got so much that you have created, you've changed so much in the foundation. I guess, will you deploy and then kind of take a step back to see how all that how people react to all this, which is a very rich offering of programs, competitions, and education? Or do you have even more new things in the pipeline?
Well, so my staff will tell you that I'm a very aggressive CEO. When I joined the REC Foundation, we had VEX Robotics for middle school and high school, and VEX IQ for elementary and middle, and we had a couple other things. And now we have dozens and dozens of programs. One of the things about partnering with VEX Robotics to run their competitions is we get to work with them on what we think the STEM community needs. So one of the things I think your audience will be really excited about is we piloted in the middle of the pandemic our AI competition. So it's the VEX AI competition. And that's hands off. That's where the students build and program 2 robots. and there's vision on there, there's GPS sensors, and basically students are doing AI. They're detecting field and game elements, deciding how to score, how to prevent scoring. So we did the pilot program last year with 60 teams, and that will be one of our premier featured new programs for the 2021-2022. On the other side of the spectrum, one of the things I'm super excited about is our new VEX Go competition. That's geared for early elementary. And the student there, it's not about winning or anything like that. It's about building a robot to accomplish as many tasks as you can. And they're very simple, but the key is you build it first, you build the mechanisms, then you add power, and the programming is optional. Because I think across the globe, so many students spend so much time on computers that they don't build as much. And I think the VEX Go program really addresses that, where students really build and they play and they have fun. And then my personal very favorite program that we also launched last year during the pandemic is the factory automation competition. So for your audience, they should know that I spent over 20 years at Fanuc Robotics. Fanuc is the largest industrial robotics company in the world. Matter of fact, the first time I'd ever been to Australia was to do a project at GM Holden in Australia, right? Yep. So, but I spent 20 years at Fanuc, and I believe, again, what I've said earlier, I believe the emphasis shouldn't be just on STEM, it should be on workforce development. So with the permission of the board and the partnership with VEX and with a grant from the Department of Defense, we were able to, over the last 2 years, develop a competition where students build small robots. They're not large robots like Fanuc, they're small robots, and they build conveyor systems. And we have STEM labs and instruction that goes with all of it. And at the end, it's basically what I would call a palletizing competition. It very much mimics like an Amazon workshop, but the students basically build robots and conveyors to move packages as quickly as possible. So our workforce development programs will be key, very center to what we do in the next couple of years. So early STEM programs with VEX Go, advanced with VEX AI competition, workforce development, and then of course drones, because I think drones is also very important to our strategy, because there are students that don't want to do mobile robotics, but everybody wants to fly a drone. So students do drones and they add sensors, whether it's a camera, and of course they have to program it. So we're reaching even more students and teaching them the STEM and technology skills. And then of course, I do expect I have very ambitious plans that our VEX Robotics competition and our VEX IQ competition, they're already one of the largest competitions in the world, at close to 30,000 teams. But I really do expect those competitions to continue to grow until we're easily the largest competition in the world.
Well, yeah, I can see it there. You're getting there. I think you're way, like the array of opportunities that you have for young people is just impressive. And the fact that it's now accessible more than ever before, in a way, ironic way, thanks to a pandemic, but it happened. It's just to show that there's so much opportunity these days for people anywhere in the world to learn and to get all sorts of skills that are also connected to industry. So thank you for taking the time then to give us this very thorough, detailed presentation of what the RSC Foundation does. I also want to mention that the RSC Foundation website at roboticseducation.org is very detailed. So everything that you talked about is documented. Just go to the website. If anyone wants to get more information, who can they get in touch with in the foundation? Yourself, someone else? Do you recommend?
Yeah, so roboticseducation.org, there's an about, and then there's a contact. And so your global audience, if you go to the resources, so it's robotevents.com/support. You can get there through roboticseducation.org, or you can type in robotevents.com/support, and there's a global map. So you can click on your country, and within the country, the territories within the country. And when you click on that, it'll actually give you the contact information. So I just clicked on Australia, and it's Jessica McGaffin. She's fantastic. Everybody in Australia will absolutely love her. She does amazing things for robotics in Australia. And so it gives you the email address as well as the telephone number But again, any country in the world, when you click on it, you'll find your person. And I also encourage the audience to go to vexrobotics.com too. So while we do more than just Vex Robotics programs, it is our biggest program. And the thing about Vex Robotics is their resources are unmatched. So when you go to Vex Robotics and you start navigating the website, you're going to find some of those free educational resources that are amazing. You'll have a link to the Vex Robotics knowledge base, which will give you all kinds of good engineering and programming support. And also you'll see some fun stuff that they have too. So I really appreciate you asking that question. So vexrobotics.com, roboticseducation.org. Between that, you'll definitely be able to get the contact. And we really hope more programs will join us. We're super excited. This is, like I said earlier, a global language. And there's nothing more fun than going to an event and meeting students from Russia, China, Kazakhstan, of course, Australia, New Zealand, Brazil, Central America. It's so much fun, but it's most fun to watch the students smile as they build their robots. And even the teams that maybe don't have the best competitive robot are still having a great time. And yes, when I see the smiles, I know that we're doing something special.
Perfect. Well, thank you very much, Dan. It was amazing.
Well, thank you. I really appreciate the opportunity, and maybe we'll talk in another year and I can give you an update of what else we were doing.
I love that.
All right, super. Thank you so much, Peter.